This video, we're going to discuss how we can implement a cluster analysis using SPSS. I'll be using the mall customers dataset that can be found on the course page, so please visit that if you'd like to follow along. Now, the first step is going to be opening SPSS and making sure that the dataset is saved in a place that you can get access to it. For me, I just have it saved on my desktop, so I'm going to go on and open SPSS. Go to File, Open Data, and then go into my desktop. Now, because this file is a CSV file, we have to read in a CSV file into SPSS. And this first involves telling SPSS that we're not looking for an SPSS data file by default. We're really looking for all types of files, and in this case, I want to use my mall customers CSV file. So realize I do have to go to Files of Type, and then change this. Now I could change this to a text where it has .csv, or what I typically do is just go to all files, and then I can see all of the possible data files that I could have to play with. Now once I select the dataset and click OK, SPSS is going to walk me through a data import wizard. I'll be completely frank with you, I don't always pay attention to each place on this, and you could sign up for our SPSS class if you're interested in what all these things mean. What I do pay attention to, though, is on this third screen where it has the data preview, I want to look and make sure that this matches what my data should look like. So real quick, I'm going to go on and open my data set to see what my data should look like. And in this case, when I open my data set, I can clearly see 1, 2, 3, 4, 5 columns and this type of information within each of the columns. When I look in SPSS, however, I don't have 5 columns. I have 1, 2, 3, 4, 5, 6, 7, 8, 9 columns, and the column names don't appear to be correct. So I can think through and pause for a second and say, hey, there may be an issue. In this particular case, what's going on is our file is a CSV, which stands for comma separated values. That's a good indicator that this comma should be checked. However, the other taskbar that's checked is the space checkbox. And in this particular case, the space checkbox shouldn't be checked. That is, this data is not space delimited. Ultimately, you'll see when I uncheck the space box, I now get the correct number of columns with the correct labels. And if you're interested, what's going on behind the scenes is there are spaces in the variable names here. SPSS doesn't like that and will take them out in the next step. But when it's reading it in, SPSS thinks, hey, maybe this is space delimited as well, and our data is not. So that's where the error is coming in. So I want to make sure space for this particular data set is unchecked. And I'm going to hit next. This is telling me that those names with spaces and dollar signs and all these letters that aren't allowed within SPSS are being fixed. So I'm just going to say, okay, thanks for letting me know. And then I'm going to click next and finish. You'll see some text indicating what was done to read the data in. I'm just going to close this output file. And now I see the data's been read in appropriately with these particular variables being read in. There's a few places to start. I might start by creating a plot. So I'm going to go to Graphs and then Legacy Dialogues and then Scatter Dot to create a simple scatter plot. And I'm just going to look at age, say, on the x-axis, and spending score, stay on the y-axis, and see how these points are related to one another. When I look at this, if I'm just trying to think through this, I might see one cluster up here in the top left, or a second cluster down here in the bottom right, maybe kind of a third small cluster down here in the bottom left. I'm not really sure. It does seem to have a little bit of separation in these areas, but it seems like a very, very small cluster, so I'm not sure if it would even count. Or maybe like this could be a cluster and that could be a cluster. In any case, I'm not sure, but it does look like there's some definitely clusters of data points going on here. I'm not really sure which one's which necessarily, but seems like there could be something to work with as far as my cluster analysis. So what I'm going to end up doing is I'm going to end up creating the cluster model using age and spending. So I'm going to go on and X out of my output, go to Analyze, Classify, and I'll just run my k-means cluster. I have age here and spending score. And I'll go on and run it with 2 clusters. And it gives me some output. It tells me where the start centroids for each of the clusters are, cluster 1, cluster 2, and this is the XY coordinates, or it's not really XY because there is no X or Y. This is just the 2 variable values. This is the movement in the cluster centers. This is how much each of them moved. And again, we're seeing 0 movement at the end. That's how we know we're done. We see where the final centroids are in terms of age and spending score. And then we see the number of cases within each cluster, and we're looking to make sure they're roughly even. In this case, they are. I'd be concerned if we have 250 total cases. Maybe I had 225 in one group and 25 in the other. I might be a little bit concerned about that solution. And that was our cluster analysis. That's all it took. We can't plot based on that yet, so I'm going to go back to Analyze, Classify, and K-means cluster, and I'm going to go to the Save button and click on Save Cluster Membership. And this is going to create a new variable in my data set, so I'll go on and rerun that. I get the same output, but now in my data set, when I go to my data set, I see a new column that's been created. I might go in and rename this column. I might call it 2 cluster solution, and then maybe I add the label to cluster my 2 cluster solution with age and spending score, and then 2 clusters based on that. And it's important to realize I could do age and spending score and have this create 10 different clusters. Or I could have age and spending score and have this create 2 clusters. So the number of clusters is independent of the number of variables used. I could have a bunch of variables and just use 2 clusters, or I could have just a few variables and make a bunch of different clusters. All right, so here I'm going to go to Graphs, Legacy Dialogs, Scatter Dot, and go to that simple scatter plot that I did earlier. And I'm going to keep X and Y as age and spending score, but now I'm going to add my 2 cluster solution in the Set Markers By box, which is going to add colors to my plot based on those markers or based on the group classifications. Here, and I find this really kind of fascinating, I see my blue group is this entire bottom, really half of the graph, and then I see one cluster has been defined, the green or whatever darker blue group, as the top left. So trying to think through and maybe interpret this, I would say that this is maybe young individuals who are spending a lot of money, and then the light blue might be individuals of all ages who aren't particularly spending a lot, and for whatever reason, individuals in the high age groups don't have a lot of spending score here. So these are my 2 clusters. How could this be useful information? Well, through identifying this, I might be able to identify, well, this particular group has an average age of 31 with an average spending score of 75. That's this particular cluster, so young, likely to spend. And so maybe I do some marketing for this particular group. I also have a lower spending group that's an average age kind of in the middle. And again, we see the age range kind of goes along the gamut. So in this particular case, this might be my group who's not very likely to spend, so maybe I do a different marketing campaign for these individuals. But if I'm going to run a marketing, I want to target it towards the younger age group within this graph because, again, these are the individuals who are most likely to spend money or have the highest spending score. It's a cluster analysis. Let's start to dive into a couple more details. So remember, one of the details that we had was how do we select the number of clusters? And we talked about how you can use hierarchical cluster analysis to help to select the number of clusters. So in this case, I'm going to go on, I'm going to X out of my output. I will go to Analyze and Classify, and right under K-means cluster is the hierarchical cluster. So I can do this hierarchical cluster. I'll go on and click on that. And my menu pop up here for my hierarchical cluster analysis. I'm going to maintain age and spending score. Under statistics, I'll keep the agglomeration schedule checked. This is how I could put together my scree plot that we talked about in class. And then I'll keep my plots. I'll check dendrogram so that I have access to the dendrogram from hierarchical cluster. And those are the two things that I really want. So I'm going to click OK to run that. I get my agglomeration schedule and my dendrogram down below. So this dendrogram, I find it difficult to read. One option you can do is to do a Word document, a blank Word document that you can paste it in. I can go up to Format, over to the side, click Rotate, and I can rotate it, I believe it's left 90 degrees, yep. I can click and drag to try to fit it into my screen a little bit better and maybe zoom in a little bit. So again, I don't care about this bottom stuff. What I really care about is the big vertical spaces at the top. And what I see for me is that 2 clusters is a very, very clear solution here. There might be 3, there might be 4 or 5. This line down here on my cursor right now looks like 5. Crosses 1, 2, 3, 4, 5 clusters. So 2, maybe 3 or 5 clusters are some different options. I can pull up my agglomeration schedule and open up Excel. I'm going to open up this mall customers data set, and I'm going to make a new Excel sheet and just Control V to paste my agglomeration schedule in there. You could also right-click, select Copy, and then come in here and in the top left-hand corner, right-click, select Paste. Then I'm going to go down to the bottom of the agglomeration schedule, and in the coefficients column D, in the bottom of the agglomeration schedule, I'm going to select the bottom 10 elements, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So look up to clusters of size 10. And then I'm going to insert a graphic, just a basic line chart that creates this scree plot. Now, for this line chart, it actually is not particularly, well, it works fine for our scree plot, but it's backwards. I can right-click on the bottom axis, and so I need to select the bottom axis and right-click, and then Format Axis. And there should be a checkbox under tick marks that allows me to change my axes, or excuse me, under labels. Gosh darn it, where is it? Oh, here it is. It's further up. I apologize. It's under Axis Options. It says Categories in Reverse Order. And this is how we can reverse our categories so that it can look more like our regular scree plot. But even in this case, note, I don't want to pay attention to these bottom axes labels. This first entry is a single cluster, not 10 clusters. So be careful about that. So here I'm looking at the first entry. It's a single cluster. Oop, I just clicked on the line, but that's kind of helpful because then I can see 1 cluster, 2 clusters, 3, 4, 5. And again, for the cluster analysis, I'm looking at the elbow. That elbow point is the one I want to select. So I see a potential elbow at 2 clusters, then 1, 2, 3, 4, 5, a potential elbow at 5 clusters. And so a 2 cluster and a 5 cluster solution are what I'm considering. Again, if you've seen the exploratory factor analysis lecture, be careful because interpreting the scree plot here is different than interpreting the scree plot in a factor analysis. In cluster analysis, we look at the elbow point, whereas in factor analysis, we look at one before the elbow, but in cluster analysis, we look at the elbow point. Again, this scree plot would suggest 2 clusters or 5 clusters as a solution. I'm going to go back to SPSS, and now that I know that I'm looking for 2 clusters or 5 clusters, I might try maybe 2, maybe 3, maybe 5 in k-means. So I'm going to go Analyze, Classify, k-means cluster. I'm going to keep age and spending score in. I'm going to still save cluster membership because I'd like to see the graph. But now I'm going to create a 3 cluster solution, and then in a moment I'm going to create a 5 cluster solution just to see what these look like. So I'm going to create the 3 cluster solution. Again, it's going to make a new variable in my data set. I do get 3 clusters, so I have 3 cluster centers and where they start, how much each of the cluster centers moves, and then where they're finally located. I see cluster 1 has kind of a middle age and a middle spending score. Cluster 2 has a low age and a very high spending score. And cluster 3 has a middle age and a very low spending score. So this is kind of interesting to see how these laid out. I see cluster 1, 2, and 3 each have relatively similar data sizes in there, so that's good. And then if I go to my data, I can see a new column has been made. Again, I'm going to go and relabel this so that I know exactly what it's saying, because that original variable is not very good. So I'm going to call it the 3 cluster solution, and in the label I'll write also 3 cluster solution. I could write more details in the label, but I'm not. It's for me at the end of the day. And then graphs, legacy dialogues, and scatter dot, I'm still going to do simple scatter. I leave age and spending score as my XY axis. I'm going to move markers off the 2 cluster solution and add the 3 cluster solution markers on. Now again, I have 2 variables and a 3 cluster solution. So what I expect is an x-axis and a y-axis, that is 2 variables, but now 3 colors on the plot instead of 2. Looking at this, I see that the cluster algorithm found the top group as one group, and then kind of the age across the age range, but the spending score being middle spending score as a second group, and then across the age range, but the spending score being a lower spending score as the third group. And this is a really interesting finding to me, not at all what I expected. And I think we'll see a solution to this in a moment when we come back and redo this with a little bit more information about what we're supposed to do. But here, this is a really interesting finding. So I'm going to note this. Maybe I'd write up a little bit on why I find this interesting. Personally, I find this interesting because this seems to be clustering much heavier on age than it is on spending score, and I don't really know why that is. Well, again, I think I have an inkling, but it's a very different output than I expected. All right, so now let's do the same thing. I'm going to go analyze, classify, k-means, and now I'm going to run it with the 5 cluster solution because, again, this was another one that seemed like it could be legitimate. I'm going to make sure I'm saving the output so I can do the 5-color graph. I can read through where the start of each of the 5 clusters is, where the changes all were in each of these clusters, and where the final locations are. And again, I can look at the numbers before I ever see the graph, and when I get to higher dimensional clusters, I have to look at the numbers because I won't be able to see the graph. In this particular case, a low age, a middle spending score, a high age, a very low spending score, a low age, a very low spending score, a high age, a middle spending score, and a low age and a very high spending score. So it looks like we've got a couple middle spending scores with low and high ages, a couple low spending scores with low and high ages, and a really high spending score with a low age. So that's our 5 groups. Here it looks like that 5th group is eating a lot more of the data. The 3rd group doesn't have a lot. So I am going to be a little bit careful about this. I don't think this is too overweighted right now. That is, this cluster, has maybe 3 times what's in this other cluster. So I am being a little bit cautious, but I'd be much more concerned if this were 10 times. So that's about the range I'm looking for. And in this case, we're not even at 5 times the sample size within cluster 5 of cluster 3. I do look at the lowest versus the highest. I don't really compare the averages. So I'm looking at lowest versus highest here. And again, those seem comparable enough, whatever that means. All right, so graphs, legacy dialog, scatter dot, simple scatter. Oh, and I realized I never renamed my cluster. So I'm going to actually X out of this menu, go back to my data set, and I never renamed my cluster to be a nice name. So I'm going to go back to this and call it maybe the 5 cluster solution. Here, 5 cluster solution. So that way, when I go to my graph, legacy dialog, scatter dot, simple scatter, I can set my 5 cluster solution. Again, I'm expecting the number of clusters, the number of dots, and I see exactly what I saw earlier in the final cluster centers, that I have 2 low spending scores with a lower and a higher age, 2 middle spending scores with a lower and a higher age, and 1 high spending score with a lower age. So I can predict from these cluster centers kind of what I'm going to see in the broader plot, and that does turn out to be what ends up happening. So as I mentioned earlier, it did seem to be weighting age heavier than spending score, and that seems to be kind of a weird thing to happen, and we can explore that. So what we can do here is consider why and how do we account for the fact that maybe it's weighting one variable more than the other. So it might be worthwhile here to go to Analyze and Descriptive Statistics and just investigate age and spending score a little bit more. What I see is that age ranges from 18 to 70, and spending score ranges from 1 to 99. Age has a standard deviation of 13, where spending score has a standard deviation of 27. And I'm starting to remember something that we mentioned in class, which was when we have a lower variation within one particular variable, it gets weighted higher in the analysis than with the other variable. And that's something that is absolutely potentially coming into play here, that my age is being weighted higher in, say, the 3-cluster solution, where it really seems to be accounting for age much more than spending score, but my spending score is not being weighted as highly, and this might have something to do with the fact that there's different standard deviations. So what I want to do is I want to standardize these variables. That is, recall our equation with standardization. I take age, I subtract the mean, and I divide by the standard deviation. So I can do this by going to Transform and Compute Variable, and I can pull up the menu. I'll call my variable std age for standardized age. And I'm going to take age. I'm going to subtract the mean, which I get from this descriptive statistics table, where I ran descriptive statistics on the age. The mean is 38.49. And then I'm going to divide by the standard deviation, 13.170. Now, I want you to be careful here. This looks right, and it is, in a way, right. But because of order of operations, this division is going to happen first. So it's going to be age minus 38.49 divided by 13. And what I want is for all of this to be divided by 13.07. So I have to wrap this beginning part in parentheses to make sure that this first part, age minus the mean, is calculated first. And then second, we divide by that standard deviation. Again, I get the mean value from my descriptive statistics for that variable age and the standard deviation value from my descriptive statistics for that variable age. I click OK to calculate the standardized age. And if I look back at my data set, now I should have standard age listed within my data. All right, well, I'm going to do the exact same thing with spending score. So I'm going to go to Transform, Compute Variable. So I'm going to call it std spend. And I need to get rid of my mean and my standard deviation because when I look at the mean of spending score, it's a completely different number, and standard deviation of spending score is a completely different number. So all of this is going to change. I'm just going to X out of it right now. And I'm going to start with my spending score. I'm going to subtract the mean, 50.24, the mean spending score. And then I'm going to divide by the standard deviation, 27.29. Again, because I want this first part to calculate first, I'm going to use parentheses to make sure that this first part calculates first before the division happens. And that's how I create my standardized spending score. And if I go back to my data set, I can see standardized spending here. All right, well, let's look again at that two-factor solution. So I'm going to quickly run my k-means cluster. But now instead of age and spending score, I'm going to use the new variables that I made, standard age and standard spending score. I run the number of clusters as 2, and I'm going to save the cluster membership and click OK. And in this case, you can see that the start of the clusters and the cluster evolution and the final cluster centers are definitely different. You can interestingly see that the number of cases in each cluster is much closer than what I had earlier. So I'm kind of curious what this graph is going to look like. First, I'm going to find my new variable, and I'm going to rename it. This one I'm going to call std two-cluster solution. Label, I'll call it standardized two-cluster solution. Now I'm going to go to the graph, legacy dialogues, scatter dot, the simple scatter. And I'm going to remove all of these variables, x, y, and I'm going to include standardized age as the x, standardized spending as the y, and the standardized two-cluster solution as the markers. So I kind of want to compare this graph back to back with the previous one. So let me go to graphs. And because I've saved my variables well, it's actually very easy to create my original two-cluster solution. So I'm going to move standardized out. I'm going to get my original variables, again, because I want to create that original plot. And I'm going to get my original two-cluster solution as my marker. So regular age, regular spending, regular two-cluster. So this gives me my old graph versus my new graph. And I want to look for similarities and differences between these. Now, on my old graph, I can see this top component was rather distinct, and then this whole age block down at the bottom was captured in one massive cluster. But up here, I can see it's actually a lot more diagonal. This lower age group seems to be capturing some lower spending participants as well as the higher spending participants, and my upper age group is kind of all lumped together as a lower spending group. So it seems to be making this diagonal a little bit better, where it's clustering all of these individuals together, and then over on this side it's clustering all these individuals together. Now, which one is better? Well, gosh, it kind of depends on which one you prefer to see. Do you want to see it cut this diagonal a little bit better so that these points are considered closer up here? Well, if that's the case, then maybe you prefer the standardized score, but maybe down here it makes more sense to you. And honestly, it just really depends on the context of your problem, which one you prefer, the two-cluster solution with the unstandardized variables or the standardized two-cluster solution, and which one makes a little bit more sense to you. In general, as a rule, the standardized two-cluster solution, again, weights the variables equally, and it doesn't account for the scale of the variables, which is important when they're on different scales. Spending is on an arbitrary 0 to 100 scale, and age is obviously age of individuals. So these aren't on the same scale, and maybe it is worth balancing out their scales when calculating this. This, just for fun, let's go to hierarchical clustering. Let's drop in our standardized variables, and let's see what our dendrogram looks like. So I'm going to run this, look down at my dendrogram, and oh my gosh, that's very interesting. I'm going to copy and paste this to my Word file and rotate it just like last time. And from what I could quickly see, this dendrogram suggests something completely different than the old one. Comparing this dendrogram and the old one really seemed to suggest two clusters was a good solution, but here I can see two clusters is frankly barely visible on this graph. It is so small. Two-cluster solution actually seems like a pretty bad solution. It seems like a much better solution here. Oh, excuse me, I just lost my graph here. A much better solution here is this three-cluster solution. Maybe even the four-cluster solution seems to be a little bit better. So I think I'm going to try a three-cluster solution based on this graphic, because again, it seems to be suggesting that a three-cluster solution is much better. So I'm going to go to Analyze, down to Classify, and K-means cluster. And instead of two clusters, I'm going to write three, again, because this dendrogram had the most vertical height to me at the three-cluster solution when I go all the way across 1, 2, 3 clusters. So I want to see how that plays out. And so I saved my results because it was on by default. I'm going to go into my variable view and write standardized std underscore 3 cluster. Label standardized 3 cluster solution. Then I'm going to make my graph with these to see if that seems to fit a little bit better. Scatter dot, simple scatter. I'm going to use my standardized variables again. Standardized age on the x-axis, standardized spending on the y-axis, and now I'm going to use the standardized 3 cluster solution as the graphs. And now I see a breakdown, and this actually kind of makes sense to me. I've got some lower age individuals who are non-spenders. I've got some upper age individuals who are non-spenders, and then I've got some lower age individuals who are spenders. And actually, this plot does seem to make a lot of sense in the way that I'm conceptualizing this. Treating lower and upper age individuals as the same plot, especially when you've got lower age spenders, seems to be a little bit of a weird solution. But this actually seems to make a lot more sense to me personally. Now, if again a previous solution made more sense to you, then you should use that. But it is worth comparing. I want to show real quick. I'm going to do the graph, the old 3-cluster graph. So I'm going to use the old age, the old spending, old age, old spending, unstandardized, and I'm going to use the old 3-cluster solution to compare back and forth. This old 3-cluster solution, again, you see it clustering much more on age because age was a lot less variable than in the standardized solution where you see these clusters as a combination of age and spending. That is, this is not just low age, medium age, high age, which is, or excuse me, all the ages here as part of a cluster with low spending, medium spending, high spending. So all of the ages are clustered together. Here you're saying the high age and the low spending is a cluster, the low age and the low spending, and the low age and the high spending. And in this particular graphic, I think this representation makes a lot more sense contextually than this bottom representation. And the only difference between these two is that I standardized my variables before running the cluster analysis. So when writing this up, there's a few things that I might talk about, and I'll just chat through them quickly here as a point, and you can come back to this video if you're interested in thinking about how you would write these up formally. It's not something I think you'll have to do in this class. In this class, you're more going to be focused on why does one of these look better than the other, and for me, I might argue, the age and spending together makes a lot more sense to have a low age, low spending group, a low or a high age, low spending, and a low age, high spending, versus just to say all the ages, and it's really just classifying on spending score and not really accounting for age at all for a lot of this. And I can very clearly connect that back to standardization and, hey, age is closer together, so the clustering algorithm is biased toward age in this particular case. And by biased, I don't mean some kind of political bias or anything. I just mean mathematically biased in this direction. And again, this seems to make more sense in terms of finding parts of the graph. That this seems to be more representative of what I see as different chunks. And so that's the kind of thing that we'd be talking about in this class, really trying to explain the big picture and what's going on and interpret. But in a formal academic setting, you actually have to go deeper than that. So within a methods section, you may have to describe your analysis plan. And within an analysis plan, I might include my method. So for instance, I might describe that I used k-means clustering, I used the hierarchical cluster analysis dendrogram and the scree plot to determine the number of clusters. I used, Euclidean distance or squared Euclidean distance or Manhattan distance within the context of this. I use standardized variables or not, and why I chose that. And so all of that information would go into my methodology section when writing an analysis like this up. It's important to realize that a lot of beginning academic writers believe that we have citations in a literature review, but within your methodology decisions too, it's really important to have citations for maybe why standardizing produces a more interpretable solution, or why not standardizing in this case is a better solution. And it's important to be able to not just provide your own arguments, but where applicable and where possible, you really want to have a citation to back that up. If it's not possible, it's not possible, but it is always considered best practice to have a citation reason for a decision that you made, if you can. So citing in the method section is very helpful. You can go back to our textbook and say, I ran the analysis as described in Tabachnik and Fidel. Of course, our textbook doesn't talk about this, so maybe I ran the analysis as described in the best practices article that we read, or as this other author did who studied clusters in a similar situation, etc. So you may really try to find a couple of good citations for supporting each of the decisions you made if you can. So all of that is actually before you even talk about these results. These results, I might include the picture. In the appendix, I might include the dendrogram and the scree plot to justify why you made the decision of the number of clusters you did. Now, in the analysis plan, you're talking about the method you will use. That tends to be in the methods section or section 3 of a paper if you're doing a 5-section paper. It's all of the things that you will use, but in the results section, you're describing, hey, I did use the dendrogram, and look, this is what I saw in the dendrogram, and maybe you even add a little line here and say, this is where I thought the highest or the best cut would be, or this is where I thought the best cut would be, and here's why I thought that. So you could include that information within maybe an appendix, maybe not the main paper, but you could cite that in your results and say, I ran the dendrogram, this is the number of groups that I saw. I ran the scree plot, this is the number of groups that I saw, etc. And then you would probably include this plot in your results and say, look, this is the plot that I have. You would clean this up because, again, you're not going to use defaults in SPSS. Actually, this looks pretty nice. You'd probably just have to clean up the x-axis and the y-axis. And if you used your nice labels and stuff and didn't just stick with the default that SPSS gave you, actually that can be helpful so that you can use this default information. Because again, it's not default. You've actually already done some cleaning up by adding in variable labels. So you could copy this over, you could clean up your x-axis and y-axis, and then you could describe what you're seeing in this plot and provide labels to your clusters, why you think this is going on that way, how you interpret that, etc. You would maybe incorporate even the number of points within each cluster to argue, you know, this is okay, this makes sense, this isn't too out of balance. And you know, you also might pull descriptives. You might list the final cluster centers. You might pull descriptive statistics of age and spending to help describe or explain this. Ultimately trying to provide evidence for your ultimate conclusion of what these groups represent. And again, it's not just interpretation, it's implication of your interpretation. So what does that imply that you do? You know, if I was writing a marketing paper, maybe what that implies is we really need to get some marketing materials out to a low age group within this particular cluster. So if I have somebody who's falling within this particular cluster, I want to get some marketing materials out to them because they have this high spending score, they're low age, so I can create a little bit more customized materials for them. And let's get that rolling because these are our spenders and we really want to get access to them. These groups, the blue and the pink, well, maybe I do, maybe I don't, but they're low spenders anyway. This is the group that I really want to hit. And because they're low age, maybe now I can make a more informed decision. That would be the implication of my interpretation that this is a low age high spender, this is a low age low spender, and this is a high age low spender. So my interpretations then drive implication. And my goal in the, not the results, but in the conclusion section is to discuss those implications and discuss my evidence for why I think those implications are justified. All right, well, this has been a presentation of cluster analysis and how to perform this in SPSS. We did cluster analysis with regular variables using hierarchical cluster analysis with scree plots created in SPSS to get the agglomeration table and then copying that into Excel to get the scree plot, and dendrograms that we copied and pasted into Word to make them a little easier to see. And then we talked about standardizing variables and redoing that, interpreting multiple graphs, both with different numbers of clusters and seeing how that makes the solution more or less interpretable, and then looking at standardized versus unstandardized solutions and seeing which of those became more interpretable in that context.